Welcome back to another YouTube Tuesday. My name is Derek, and today I'm going to be going over a YouTuber that you should definitely be following, especially if you're looking into learning how to repair laptops, consoles, although he does cover other things as well. That channel is Northridge Fix. Northridge Fix has almost 500,000 subscribers and has uploaded over 1,100 videos. Today we're going to be watching one of his more recent videos that'll show you another way to diagnose and fix a short. And this method he is going to use applies to all electronics, not just, I believe he's working on an iPad here. But it can be used to troubleshoot shorts on basically anything. Let's get into the video.
Five that came in for repair, iPad 5th generation, and this one is model number A1822. Customer said it does not power on. Who fixes an iPad 5, right? You'd be surprised. A lot of people. They do it for the sake of just fixing the tablet. They have applications that they need, or maybe they have photos inside, or maybe data recovery, whatever the case may be. We got the tablet in for repair, and let's read what the customer wrote. Screen went black while in use. Tried to turn back on, no joy. Tried the reset home button with power button, no joy. Tried to charge for an hour and try all of the above. Again, no joy. Went to YouTube, saw your iPad repair for 5th generation, same as what I have. Looks, sounds, feels like an inline capacitor. You'd know better than I, so I left it closed for your inspection. iPad has never been open and it is relatively new use condition. From one tech to another, thank you for your help.
That definitely sounds like a issue with the capacitor. If you suddenly, for no reason, have a device that goes from working to not working that quickly, it's almost always a shorted capacitor. Typically, it's obvious if it's going to be something else like water damage or a drop or something like that that would cause it to be something else. But it's almost always a capacitor if it just shuts off like that.
Now, the first thing we did was plug the charging cable in. The tablet is charging at 5 volts, 1.1 amps, which is 100% perfect. No issues at all. Usually we see a 0.6 amp charge. We see a 0.48 amp charge. We see a 0.7 or 0.8, which could be an indication that we have a problem or a short circuit on the board. I went ahead and did a visual inspection on the board. I did not find anything obvious. I did not plan to record the video, but now I thought, why not? I have a lot of iPad repair videos on YouTube, 1 million videos on iPad repairs. Let's make it 1,000,001, right? Why not? Put the brightness up. Usually I look in this area. I see if there's a hole on that piece of whatever, piece of fabric. If we have any holes, a hole is an indication that something got hot below or something blew or something burned, but that shield looks good. Nothing burned under.
The hole typically is something that I'd see when a fuse or a filter has gone bad. It'll literally just burn through that little sticker, and it's pretty obvious that it's the culprit that's causing the issue, whatever issue you're having. So it's a good place to start on really any iPad.
If we lift up the shield, we see components. We have components around the connectors. And no reason to believe that we have any issues here. Right now, the tablet does not power on. It's not like it powers on and we do not have an image, or we have a backlight and no image. No, the tablet is not powering on. So before I decided to record the video, I went ahead and probed around. I probed and I came across a short circuit. Let me show you. Right now, I have the battery disconnected. You never want to measure with the battery connected. If you look here, meter in diode mode, we are reading 0.000. And we are reading 0.000 voltage drop. So that's it, that short. If we go to ohms mode and we probe again, what is the ohm reading on this cap? 0 ohms. I mean the diode. And we have 0 ohms. So that's that short here. Now, if we probe around this power IC here, let me go to diode mode. See, we have it that short. We have all zeros. Every single one of them is a 0. All those caps are connecting in parallel. And one of them must be shorted to ground for all those caps to read a short. Or it could be the chip itself. Who knows? So I got that far with the repair. And then I pushed the record button. And now we have a video. And if that short is on, our voltage injection tool, I'm going to connect the ground probe anywhere on the frame here. And we're gonna inject voltage. We can inject voltage anywhere on the caps, or we can inject here. And we're gonna monitor the board under a thermal camera and see what gets hot right there.
Now, this is one way to definitely diagnose it. If you have a good thermal camera, you will be able to pinpoint the component that is getting hot. But some of you may not have a thermal camera, or you have a thermal camera that just gives you the general area, because it's kind of hard to focus on which component, given that they are so small. Sometimes it's hard to know which of the dozens of components that are around the hot spot is the actual culprit. So we're going to look at a technique that he uses to troubleshoot this.
See it? If I release the probe, heat spot goes away. I put the probe. We have a heat spot. Let me do this one more time. We have a heat spot right in the middle of the chip on top, right here. Right here. One of the 4 caps right here. I was not able to pinpoint which cap, but maybe we can use our atomizer to pinpoint where the short is coming from. Or maybe if I put the brightness down on the LED and we look for any discolored cap, maybe that could be an indication. Let me tilt that iPad quick.
Sometimes it's obvious which cap it is.
Does any one of the caps look obviously bad? I mean, I see something here. Heat was not coming from the first cap, which is this guy here. I do see a red circle, but heat was not coming from here. Heat was coming from here.
That first cap with that circle-looking thing on it, I've seen that a lot. And when you scrape at it, it tends to be like a drop of underfill, and so it doesn't. It kind of looks like a hole. It looks like it could be something like a short, but most of the time, if they're not discolored, it's just a little bit of underfill that was dripped on it from whenever the underfill was put around the IC.
Yeah, because this one looks off. This right here looks off. But should we follow what we see under the microscope, or should we follow our thermal camera? Maybe we have more than one short. Who knows? Okay, I'm going to use our atomizer. Just drop some flux powder. I press down on the button, and then the atomizer is going to release flux powder. Okay, I'm not sure if you can see the flux powder. Then just push down like this. All right, so we have
It doesn't look like he was able to get a ton of the rosin to spread over the board. He's got a small coating. The main thing that you want to do is you want to be in a room or an area that has little to no air movement, because you need the little atoms of the rosin to want to settle. And they basically become airborne like smoke, kind of almost looks like, something you'd smoke with. And it needs to settle on the board. And it's not the easiest thing to control where it wants to go if you've got air movement. So it's a light dusting that he's got here, but at some point you'll get used to seeing the slight change that'll help you identify the component that's gone bad.
Flux powder everywhere, right here. Now we're gonna inject voltage and see. Okay, so the way I see it, I can already tell which cap is bad.
It's very subtle.
Can you see it?
Very subtle, the change in the caps there.
Write it down in the comments. Do not cheat. Which cap do you think is bad? Let's count. 1, 2, 3, 4, 5, 6, 7, 8. Which cap is bad? Write it down. No cheating. Do not fast forward. And I'll tell you right now, based on what I can tell from the flux powder melting, the problem is this cap right here. This is the only cap that changed color. You can tell that this cap is darker than the rest. We still have flux powder on the rest of the components. Of course, heat is going to transfer over to the other components, but I released my probe on time before all of them sweat.
So basically what'll happen is the rosin core, the rosin, the flux will melt and it'll become glossy, and it'll basically show through the color of the component. So he could have upped his power supply and injected more voltage, and it would have gotten hotter and it would have melted more. So it would have been more apparent, but he's basically using the bare minimum amount of voltage that you would want to put through that line to find the short. So he was able to pick it out. Now, if you watch it back again, you might be able to see the slight change. It's very, very slight. There are other methods than using this. There's using freeze spray. There's using a good thermal camera. There's using alcohol. There's using just your finger to touch and try to isolate it. Sometimes if you touch it, you can literally feel a burn, and that's completely valid way to do it. But But this method is cheap. The atomizers are really inexpensive. The rosin that you get as well, they're fairly easy to use. Again, you just need to have an area that doesn't have a lot of air movement. Otherwise, it's just gonna blow all of that all over, and it's gonna blow all of the little atoms away from the surface that you want it to stick on.
And this one is the darkest one, which means this is the component that's sweating the most. Flux burned off that component first. Let's go ahead and remove the component, and hopefully that's our bad guy, the culprit. And how are we gonna remove that component? Are we gonna use hot air? No.
Look it up.
Are we gonna use a soldering iron? No. Are we gonna use a spudger? What do you mean a spudger? How are you gonna fit a spudger here? How are we gonna remove it? Easy. Just put the tip of your tweezer right here and flick off. Done. What in the world did you just do? Let me worry about that part. Let's go ahead and test. Do we still have a short? Before we read a short right here. And look at this. 0.16 voltage drop. We do not have a zero reading anymore. And now if we measure the caps here, that's ground and that's not ground. 0.16 voltage drop. You see? Look at this. Look at this. We pinpointed the bad guy, the faulty cap. We flicked it off. And we're going to keep it that way. We do not have to replace that cap. We have a lot of caps around that chip. All those caps, they work in parallel. I gave that example so many times. If you have 100 police officers guarding a building and one of them called in sick, it doesn't matter. 99 are still guarding that building. So why did the factory put that cap in if it's not needed? It could be code. It could be code, or it could be something else. Like if you open a restaurant in California, they force you to have a sink to wash your hands. They force you to have a sink for mopping the floor. You clean the mop with that specific sink. And then you have a sink for the bathroom. And then you have a sink for washing dishes. You need like 4 or 5 sinks inside that restaurant. You only need one, but you are forced to have 4 or 5 sinks. The other thing is, replacing that cap is a bit risky. The area is tight. Maybe we go in to replace that cap and solder a new one. We end up knocking off other capacitors on the board because the area is tight. Or maybe we knock off the chip. Why take that risk? The tablet will work 110% without that cap. And I'm going to hand the tablet over to Big Boss to reassemble and test. And I'll be back to finish the video. All right, so we put the screen back on the tablet. We did not fully reassemble the tablet. We have a separator between the screen and the housing. And I told Big Boss not to turn it on. I want to do it on video. Okay, so 1, 2, yes, amazing. I did not have any doubts, not for 1 second, that the tablet was not going to power on. We had a short circuit, we got rid of the short, and the tablet is working. Thanks to this amazing tool here that was able to narrow down which cap was the problem. I hope you enjoyed the video. Let me know what you think of it down in the comments. Don't forget to like and subscribe, and we'll do something else in the next video.
All right, so there you go. Now you might be asking why I picked this video. And that's because learning how to do stuff like this, learning how to troubleshoot shorts, if you're able to do that, you'll be able to help those clients that come into you with dead devices. And on top of that, it's one of those things where the repair cost is only your time. As you can see, he did not need to replace anything. He could have replaced the cap. There are ways to do that, but it's not necessary, as he explained. And the value of the device versus the amount of time that it took him to diagnose and solve it allows him to make a decent profit margin while leaving his customer satisfied with a working device. So if you learn how to understand how to troubleshoot shorts or troubleshoot components that have gone bad and replace them or remove them, you will find that the cost is almost always just your time. Well, that's it for today's video. If there's a specific channel that you'd like to see in a future video, let me know in the comments below. Feel free to check out the past 5 weeks where I've shown individual channels as well. And if you like Northridge Fixes content, like the video, and we'll see you tomorrow for our Micro Soldering Wednesday.